Matthew, what should the intro be like?
Hello everyone. So this is our Python course. My name is Matthew, and I guess we'll get to introductions. So hi, my name is Matthew, and I am the team captain of our team 99909A, Rising Phoenix, and we've been doing robotics ever since I was in 5th grade, so a couple of years. And so some of my hobbies, I like playing tennis. I like playing around with robotics. I love programming. And currently I go to TJ. I am a rising sophomore, rising 10th grader. And um, I also love doing math competitions. And this is Daniel.
Hi, I'm Daniel. Um, I'm a seventh grader at Cooper Middle School, and some of my hobbies are swimming, robotics, playing games. I also like to cube.
Hello, my name is Pranav, and I'm a rising 10th grader like Matthew, but I go to Basis. And some of my hobbies are playing soccer and obviously doing robotics. And I also like doing science competitions.
This is David. Unfortunately, he is not available right now, but he is a rising sophomore as well, and he goes to Langley.
Hi, I'm Cynthia, and some of my hobbies are, of course, robotics and swimming, and I go to Langley, where I'm a rising sophomore, rising 10th grader.
I'm Sophia. I'm a rising sophomore at TJ, and some of my hobbies include soccer, games, and I also code a bit of Java at school, and obviously robotics.
Okay, so that's it for introductions. Um, as we've said before, uh, we are team 99909A, and we've been doing robotics, and we've gone to like the World Championships, and today we're here to teach you about Python. And in order for us to learn about Python, we're going to need to go to the very basics. And starting from the basics is the actual hardware of the computer. And obviously the most basic particle that you can go to is the atom. And we're actually going to get to that later on in this presentation. So first off is the kind of different portions of the computer. So that would include everything inside this computer, as well as the monitor and all your input-output devices. So a quick overview of what's inside the computer. So this computer anatomy contains everything that you could possibly need. And so this is essentially a bigger version of what you would find inside of a common laptop. And this is a desktop view. So we have the main processing unit over here. This is the CPU located right around here. And this entire green board over here, this is called the motherboard. So this has like most of all the electrical components. It's semi-delicate, and it will control practically everything, hence its name, the motherboard. Next is going to be the heatsink. So this heatsink, you can see it is located directly on top of the central processing unit, and the reason for this is because since it is the central processing unit, it will be going through doing a lot of calculations, and so this will heat it up. And so without a heatsink, this CPU would easily overheat, and when it overheats, things malfunction. And although there are many safeguards that will either shut down the CPU or slow it down to cool it off, the heatsink allows the CPU to run for much longer periods of time without overheating. Now, next over here we have the RAM. This is also located on the motherboard, and so the RAM is essentially a memory, and typically over here each stick will be around 8 gigabytes of memory. Now 8 gigabytes per stick, so in total over here you would see around 16 gigabytes of memory. And so what this memory is it is the active steps or active things that the computer is going to need to process. So every action that you tell it to do, say you want to open up a window, and then on the window you click on a certain website or a certain link on it. Now first it would send the command of opening the window or opening the website to the RAM, and then after you click that URL, then it will then send the instruction of opening that URL to the RAM as well. And so it will send each command through into this data structure known as a stack, which we may cover later on. But essentially what happens in a stack is whatever last action you added is the action that will be performed. So if you were to spam click like reloading this website, then every single time you press reload one more time, then what that will do is it will send the same command over and over, which is why if you were to spam a certain command over and over again on your computer, it will never load, because you're simply sending it more commands and you're filling up the RAM more and more. Now, The RAM is only immediate access memory, or the random access memory over here. The bigger memory comes all the way over here. So this is the hard drive, and sorry, right here, hard drive. And so the hard drive, it can be there's two main types of hard drives. So there's an HDD and an SSD. We won't get into the details of these, but those are the two main types of hard drives that you will find. Now, what's so special about these hard drives is that they have massive storages. Now, typically on a computer, you can find anywhere from 500 gigabytes to 2 to 4 terabytes of storage. A terabyte is a unit of storage which is even larger than a gigabyte. And so all this storage is every single file you will ever download. Everything you download onto this computer is stored in the hard drive. So whether that be an application you download, or a picture you download from the web, or a presentation you download, or a document you get for school, everything is stored on the hard drive. And so the RAM will access everything from the hard drive. So essentially the hard drive is feeding information into the RAM. And so now we can see all the data is obviously stored in the hard drive, and then gets sent to the RAM, and the RAM will send it to the CPU for it to process. And we can see this all kind of works in a system. Now, obviously we need a power supply, so all of these electrical components can work, because each one needs optimal electrical, it needs power to run, essentially. And so power supplies can vary from 300 watts to 700 watts. That's the normal range. And so our final piece in this entire CPU is going to be the expansion slots. Now the expansion slots is anything ranging from your keyboard input to your headphone input to, say, a speaker output. Everything that you use to attach to this computer, even a monitor, everything is attached through the expansion slots. And so these expansion slots are very important, as they are the basis of input output. So we're going to cover each piece in more detail throughout this presentation, and we're going to go through with some more detail in another presentation about the specialties and how important they are to the computer. Okay, so here we see what's inside a computer system, and so inside this is the system unit, so that's essentially everything you see over here. So as I said, there's the motherboard, there's the CPU, there's the memory system clock, ports and expansion slots. These three over here, they aren't too important, but they are important in making sure that you optimize your computer speed. These two are going to be the most important, and what we're going to be paying attention to in the rest of this course, as it allows us to understand how a programming language is able to manipulate the computer and its memory. So what's exactly inside a computer? So as I talked about here, the hard drive, it can compare between an HDD and an SSD, and so these two are essentially two different ways companies designed a hard drive in order to maximize storage in as small of a space as possible, and creating as little sound as possible as well. You also have optical drives, which includes CDs and DVDs. You have your basic input-output devices, everything you kind of need in order for ease of access to the computer. And finally is communication devices, which is the Wi-Fi adapter. You can use Ethernet, or you can use wireless connection. So we need to get into more detail with the CPU, memory, and hard drive. So memory over here is referring to the RAM, not the RAM and the hard drive. It is just the RAM. And so as we get into more detail with these, we can start to understand how the computer can turn the actual Python code that we write into computer code, so that it can run whatever instructions you told it to on the CPU. So the CPU is pretty intuitive. It's essentially something that processes lots of calculations at once. Now, why calculations? It's because it uses something known as binary, which we will get to later in this presentation. Now, in the CPU, processing instructions is essentially just performing each one of these binary calculations over and over and over again. And so you may be wondering, well, how does it calculate, how does it say add two strings together, which is something that we'll learn later on in the Python course, by just adding the binary numbers together? Well, binary can represent anything as long as it's given enough storage space, and so that's where we can learn about what a bit is, and so we'll see that later on in the presentation as well. And so the CPU, it will get all of its data from the memory or the RAM, and so we'll talk about the RAM now. So the RAM is essentially a temporary storage. So temporary is very important because it is a very small storage. However, this small storage is organized in such a way that it will kind of get rid of all of its stuff inside the storage as fast as it can. And so what it will do is it will store the instructions for the CPU, known as opcode or computer code, and its data. So essentially, in order to process any instruction, you need to know what to do and the data that is needed to do it. And so these are the two bases of how you can basically make sure that the CPU will get all of its information that it needs in order to process the instruction. And so it will get all this data from the hard drive. And so the hard drive is essentially the permanent storage of the computer programs. You can obviously clear the storage, you can add to the storage. Most of the time the computer storage is so big that you will never need to delete anything, which is why it has to be so big, because it stores everything that you could ever need. Now we'll get into one of the more specific presentations over here. Alright, so over here, this is an actual picture of a CPU. So it is a very small chip, as we can see, almost about 1 inch by 1 inch, maybe slightly larger, and it's very thin, and it doesn't look like much, but when you kind of open up the cap, you can and lift it up, you can see that there's all these connections to the motherboard, and you can see about, I would say,
Okay, so
you can
this
see a
is
lot of connections.
what a CPU looks like. This is a CPU made by the company AMD. So like as Matthew said earlier, it calculates the instructions of the computer's programs, and it's like the mastermind of the whole computer. So this is what a motherboard looks like. It always has the CPU slots, the RAM slots, the PCIe slots, and then the ports. So that big square in the middle is obviously where the CPU is placed. The channels on the right are where the RAM sticks are placed. On the left side, in these are the ports that allow for connections such as USB. Finally, on the bottom, are the PCIe slots. It's as Matthew said earlier, it's an interface for connecting GPUs and other power-demanding electronics. Obviously, there's more stuff on this board than just these 4 things, but these are the basic parts. So this is a stick of RAM, and as Matthew also said earlier, it's a temporary storage for the computer. So the gold connectors on the bottom fit into the motherboard's RAM slots. It's pretty simple to install. Next is the second most power demanding part of your computer. This is the graphics card or GPU. So the graphics card actually has its own kind of, you can say, CPU per se. It's the device that actually calculates the computer's graphics, and the GPU also has its own RAM called VRAM. This is because it's has to be close to the GPU for a fast output, because the main RAM is too far away from the GPU. And then on the left side, there's a port that allows the GPU to connect to a monitor. So this is a power supply. Obviously, it powers the computer. There's nothing really else to say. So now I'll talk about the differences between a solid state drive and a hard drive. Both are long-term storage solutions for computers, but in the SSDs, they're much faster than hard drives. Like, you can't even compare their speed because the SSD is just way faster. It's also smaller and lightweight, better at surviving falls and damage, and then it's good for storing programs that are frequently used. However, it's a lot more expensive because the the price per gigabyte of storage is higher than that of an HDD. On the other hand, hard drives are slow, they're really heavy and large, and then falls and scratches can easily damage a hard drive and corrupt its memory. It's good for storing programs that are like infrequently used or storing archives. The main advantage of hard drives are that they are cheap and they have very low cost per gigabyte of storage.
So that wraps it up with the main components of a CPU. And so now we will move into the electrical components of a CPU.
A computer is basically an electrical system. It's just a really complicated electrical circuit. It can be turned on and off, like the lights in your house or your computer. As you see, the picture below shows the different states of the light bulb, on and off, also known as binary 1 and binary 0. The picture on the right has a light bulb that is on because it has a closed loop, which allows a current to flow through the system, while the picture on the left has an open circuit, which stops the current from flowing. To understand how an electrical circuit forms and what happens when it is flowing, we need to start with atoms. An atom typically consists of electrons and a nucleus made of protons and neutrons. Electrons will repel from each other from other electrons because they have the same charge, but will be attracted to protons because they have opposite charges. The electrons are then pushed and pulled, creating the flow of charge we know as electricity. Electricity plays an important role in running a computer. Pressing the power button on your computer will supply other components of the computer with the proper amount of electricity. Once all components have been powered, the transistor will send a signal to the motherboard and CPU. Then the CPU will receive a signal that tells it that it is ready to receive instructions, which is when you can actually start using your computer.
These are the two states of an electrical circuit. As we said before, there's the state 1, binary 1, or on, and binary 0, or off. So, an electric circuit, it can form a closed loop when the everything is connected by wires from the battery all the way to the light bulb. So this is a closed circuit without a switch, so the light will remain on until the battery runs out of power. And so over here we can see there's the switch, and so what this will do is when the switch is when it touches this side of the wire to this side of the wire, then it will turn the light bulb on. And so this is the premise of what happens inside of a CPU. And so essentially inside the CPU, you will see a lot of these switches essentially, and so that's how it can compute these binary calculations, because it is able to manipulate all of these switches and perform actions. So that brings us to signals. Now, signals is essentially anything that can convey any sort of information in any way, and it can be encoded, or it can be any kind of basic hand signal, such as like waving to someone to say hi or something like that. And so some signals can have like multiple different kind of gestures. You can have multiple different hand movements, or you can say different phrases. Now, the signal that we are going to be talking about only has two states. It has a long state, or a long pulse, and a short pulse. And so the specifics of this signal is you can kind of see how this chart is organized. And so this chart over here can kind of show us how the CPU can kind of understand the instructions that are passed to it from the RAM. And so, as we can see, this binary can quite easily encode every single letter and every single number. And so it can keep on going up, and essentially, in order for it to encode more characters or more numbers, all it needs to do is either increase in length or change up its pattern. And so the different number of combinations that you can create is essentially 2 to the however many characters there are. So if there were 5, then we could do all the way to 2 to the 5, or 32 different characters. And this can all be represented just using the long and short pulses. Now, digital signals. So digital signals is it's a signal, of course, and so it's essentially a continuous stream of alternating rising and falling edges. So this does not mean that this represents a 1 and this represents a 0, but rather this falling edge over here, going from the top to the bottom, represents a falling edge, which means that it is a 0. And this edge, which goes up to a 1, represents 1. And so each of these kind of edges can represent a bit. And so this bit is it's the smallest unit of storage in computers. And so this unit of storage can only store one number, and in this case it will store either 0 or 1. And so as we can see over here, there are 8 bits in total. And so these 8 bits in total mean that it will form something known as a byte. And so a byte is classified simply as 8 bits. And so we want to know, what exactly does this stream of 0 and 1s represent? So we are thinking about the 0 and 1s in terms of binary. So essentially this would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to 3, all the way up to here. So I'll give you guys a second to think about it, and we'll check with the answer on the next slide. And if you guys can perform that calculation fast enough, then you can try and figure out which character it might represent. Okay, so now that you guys have had some time to think about it, we're going to check our answer. So, I believe it is over here. Yes. So this is the answer. And so this 1 byte over here can represent the numerical value of either 76 or the capital letter L. Now it's important that it is capital and not lowercase. Alright, so here we come into the number systems, and so this is essentially more examples. So we can see that there's base 10, so this is our normal base. This goes from 1 to 9 and in the ones digit, and it will perform that in each kind of bit. And next we have hexadecimal. Now you notice in this hexadecimal we see C over here. So this can get quite confusing, although essentially what C means is there is no number after 9. So they have to come up with something to represent it. They can't put 10 because that would take up 2 digits. So instead of going to 10, they use A. So essentially C means 12. And so this is how the calculation is performed. And so we see this in binary. And so binary obviously only has 0 and 1s in its digits, and so that's how it's calculated as well. And this is the digital signal that we saw above. So quick couple of definitions. So a byte is a group of 8 bits. So this is very, very important as we go on in this course. And so these 8 bits, they can go through each one of these possible permutations, and so this will make around 256 possibilities, 2 to the 8. Second one is memory. So a memory is essentially a long sequence of bytes. So they are all numbered in order to organize it. So byte 0, 1, 2, 3, and it goes on until the memory will end, the memory sequence. So that's our quick 2 definitions for today. And this is an ASCII table. So an ASCII table is not something you will ever need to know unless you are looking to go after this profession and want to kind of study how a computer works in more detail. This is kind of a chart showing how many possibilities that this small binary approach can, how many possibilities this can create. So we can see that there are in total 127 different permutations that we see over here, and it covers everything from different controls all the way to all of the characters, all of the numbers, and even special characters. And so our final kind of lesson for today is going to be about binary addition. So binary addition is essentially adding binary numbers together. So if we were to add 1 and 1 together in base 10, we would get 2. However, in binary, there is no 2. So what we do is essentially the same thing that we would do in base 10 if we had 5 plus 5. We would carry over the 1, and it would be added to the next. So we can perform this calculation here. So 1, 1 gets 0 and a carry, and we have 1 and 1, 0 and another carry, 1 and 1, 0 and another carry. Now we have 3 1s here, so we get a 1 here and a carry, and we have 3 1s here, so we get a 1 and a carry. So this quick binary calculation gets us 111000. And so finally, we're going to go over the actual ways that the computer will switch the states in the next class. But this is the last thing. So the switch states. So we can understand. We can need to make sure that we understand how the binary can go from 1 to 0, and from 0 to 1. And so there are many different mechanisms that the computer can use. And so that's what we'll go over later. If you have any questions, make sure to ask them. And tomorrow we will have office hours. And so the office hours are for questions that say you couldn't think of, or any questions you have on the homework problems. So these homework problems, of course, are not mandatory, but they are very useful in helping this learning progression. And so if you don't know where to find them, all you need to do is go to capitalrobotics.com, capitalroboticsclub.com, and you can just scroll down and you can access the course materials on the GitHub right here. And so you just click on the folder, click on assignments, and then click on Python assignment 1. And you can see a quick recap. You can see all the different assignments, and you can see even a reference if you get confused. I guess that is all for today. I don't see any questions. Thank you for listening, and remember, next class will happen on Thursday at 5 p.m. Sorry, Friday.